audible to you?
Yes, sir, you're audible now.
Yeah.
Nirmit, you can start now.
Yeah, thank you. Thank you. Shall I proceed, Shiva?
Yes, sir.
Good morning, everyone. I am Nirmit Mishra, Assistant Professor in the Department of Aeronautical Engineering at MLR Institute of Technology. I welcome you all on the virtual platform of 2-week faculty development program on recent developments of nanocomposites and smart materials in aerospace industry, approved by AICTE on the day 3. I welcome our resource person for the day 3, session 1, Dr. G. Raja Murugan Garu. He is an associate professor at School of Mechanical Engineering in Vellore Institute of Technology. He has an experience of more than 15 years in academics and industry in the area of welding engineering and material science. He is currently working on 2 funded projects, and he has more than 50 plus journal publications and 10 conference journals on international platform. I welcome you, sir. Thank you for joining with us today. Now I request Dr. Raja Murugan Sir Garu to take over this session and guide us to enhance our knowledge in these materials.
Thank you very much for your kind introductions. Is it audible to you?
Yes, sir, you're audible, sir.
Sir, shall I stop sharing? If you want, you can share.
Yeah. You stop sharing, so I can stop from my my side. Is it visible to all?
Yes, sir. It's
Yes, sir.
visible.
Yes, sir.
Visible to? Yeah. Okay.
Yes.
Right. Okay. Thank you very much for your kind invitation, for giving me an opportunity to present to share my knowledge, whatever the experience I'm having in composite materials. Okay. So it may be, I think today's class I'm just going to give an basic idea about the metal matrix composites, and later on I think I have one more session on 14th of September. So by the time I can explain in brief about what are all the research opportunities which are available in this particular metal matrix composites, and what are the current trend which is going on, and how one can work on this particular area in the future work, right? So today I'm just going to touch the most of the basic knowledge, basic idea about the metal matrix composite, right? So first of all, we should know what is the importance of composite material. Why everybody is saying that composite material like that? Because I think you all know that composite is basically the weight to strength ratio. There is a major point one can select this composite material, because when you if you take a steel, it can give more strength, but when you compare the weight, it is much more. So even though it is giving excellent strength, but the weight ratio when you compare to this composite material, it is in the higher order. So in order to minimize the weight, and as well as I'm not going to compromise the strength, then you have to go for the composite material. Okay, and in this particular section, or in this today's lecture, we are going to discuss about what is composite material and how they are manufactured with the different techniques, and what are all the advantages, and in all the composite may have some drawback also. So how can I overcome the drawback of this composite material, and what are all the developing mathematical models which are available to fabricate this composite material, and by using of this mathematical model, how can I design the particular composite structure. So I think just now I told you composite is nothing but, if you want to get a weight to strength ratio, if you want to make a product which is very good strength to weight ratio, then I can go for this composite material. And how can I define this? So it is a structural material which consists of the combination of two or more constituents. Maybe it may be more than two, I can say. I think in the recent trends, I think most of the researchers, they are all trying to add, different type of reinforcement, and they are adding different type of structural reinforcement, and the combination of structural reinforcement and as well as the particulate reinforcements. Okay, there are different type of research which are all going on in this particular area. For example, the flush in your leg reinforcement with bone. Okay, so in your body part, in your bone, if you want to strengthen, or if you want to have some bolt, if you want to connect the broken bones, and still they are using titanium composite material because it is having excellent strength, and that particular material should not react with your chemicals which are available in your body. Okay, so that is very much important. So in the biomedical field, most of the the metals, instead of going for normal metal, they will go for composite metal. Then concrete reinforced with the steel. So I think a simple example, we all know that in the civil engineers, they are constructing a building, right? So how they are constructing, how they are manufacturing or fabricating the beam or column. So with the help of sand, with the help of cement, and with the help of the steel rod. So when you mix all this together, then it is a combination of a composite. I think somebody may have the doubt. So what is the difference between composite and alloy? Alloy is also a composite? No, it's not a composite. Then why you are saying that it is a composite? It's a combination of this steel, this stone, cement, and the sand. It is a simple example for a composite. But what is the example for an alloy? For example, if you take a brass, so brass is an alloy. I can't say it is a composite. Why? Because it's a combination of copper and zinc. It's called brass. But when you see the microstructure of a brass material, it's an alloy. Okay, when you see the microstructure of a brass material, you couldn't find where is the copper and where is the zinc. You can't differentiate between the amount of this copper and the amount of zinc which is present in the particular brass material. But while manufacturing the brass, you have to add 63% of copper and 36% of zinc. Then only you can able to manufacture a brass alloy. It's a copper alloy, right? But whereas in a composite material, after fabricating it, when you break this structure, when you break any composite, and you can able to find the individual steel, individual stone, individual cement, and individual this sand. So all are put together, it is a structure. But if you look into deep in the internal part, all are equal, all are not combined equally. They are all merged equally. It looks like a merged structure, but it is not merged equally. It is not diluted and is merged. But whereas in alloy, the metals, the alloy, whatever the alloy you are going to add in the particular fabrication of the material, so those are all mixed together to make that. Okay, so that is the major difference between the composite and your alloy. Okay, and for example, if you go for an the fiber matrix composite, where you require a resin. So resin is a major matrix. So resin will give you the bonding between the fiber and the whatever the reinforcement you are going to add. Okay, so this is the different approach. There are different type of composite materials are available. So each and every composites should have a binder, should have a reinforcement, and if you have, the type of reinforcement may vary, the type of, the length of the reinforcement may vary, the diameter of the reinforcement vary. So based upon the, the criteria, whatever the reinforcement you are adding, whatever the, binder you are going to add, based upon that, the strength may increase or decrease, right? Now, so just now I told you what are the composites, what are the advantages and drawbacks, we will see in later. And what are the influence, what are the factors which influence the enhancement or, decreasing the mechanical property of the composite. We'll see later. And how the composites are classified, and what basis these composites are classified. And what are the common type of fibers in a fiber matrix composite, and how the composite materials are manufactured. In this section, I'm going to discuss about the manufacturing of metal matrix composite, and what are the mechanical property one should expect the metal matrix composite. I think we all know that mechanical, most probably after fabrication of a composite material, we are looking of the enhancement of mechanical property. It may be a yield strength, it may be a modulus, Young's modulus, it may be a elongation, or in some case it may be a fatigue strength, and there are different type of property like tribology property, or even your corrosion resistance property. Okay, so these are all the other type of property one can expect, but the expectation of properties depends upon where you are going to apply this composite, that is matter. Okay, so based upon the application only, I can expect the property from the composite material, and based upon the expectation of your the user end, you have to enhance the property by adding of or by the selection of the appropriate matrix, and as well as the reinforcement in a particular. So then, before going to fabricate this composite, we should know who is the end user of this particular material. So, of the composite, very important, not only for the industry. Even if you want to do some research, or if you want to do PhD in a composite material, so first of all, you should know what is the gap in this particular area, right? So how can you know the gaps are? So you should read, most of the literature surveys, and they are, estimating the mechanical property, tribological property, or even corrosion property, vibrational property, and all. But what for they are expecting this particular property from the particular material? Because the end user, and where they are going to use this particular composite, that is application point of view. That is very much important. So without that, it is very, nobody will accept even your paper or even your thesis. Okay, so the situation is like that. So you should understand the application or end user of the particular composite. Based upon that only, you have to enhance the required property of the particular composite with the addition of the different categories like matrix, reinforcement, so on. Okay. Then the composite will also enhance the tripod. Just now I told you the terminology is used for studying the mechanics of the composites. What is the mechanics of composite? What are all the factors which influences? How can I avoid these factors? How can I overcome those particular factors? So that we will going to study in this. The advanced composites, the composite. Okay, there is some advanced composites, and nowadays they are creating a different type of advanced composites. So these advanced composites are a material which are traditionally used in aerospace industries. I think most of the composites are used, I think more than 70 to 75% they are using it in automobile industries, and 10 to 15% they are using in aerospace industries. Okay. Because in automobile, I think the mudguard or the engine blocks, okay, if you look in the cars, the front dashboards, okay, and the parcel trays on the back side of the parcel trays, okay, and the door panels. So most of the recent cars, they are using this composite material because it can give more strength and it won't increase the weight of the car. That is a major plus point of this composite material. That's why most of the automobile manufacturer, they are focusing on the composite material. Okay, so examples like the graphite, epoxy, Kevlar, Kevlar plus epoxy, or boron and aluminum. If the first two comes under the fiber matrix composite, that is a combination of graphite and epoxy. And second one, Kevlar and epoxy, again it comes under the fiber matrix composite. And third one, boron and aluminum, it comes under metal matrix. So what are all the different type of natural composites? Natural composite, simple is your wood. Okay, it is having a cellulose fiber, a lignin matrix. So I'm not going to explain in deep because it comes under fiber matrix composite. Okay, and if you talk about the bones, again bone is one type of a composite. It's having mineral matrix. Okay, and it's have some collagen fibers also, right? And basically, if you talk about your fiber matrix composite, how it can be manufactured? It can be manufactured by adding of the fiber plus the matrix, and in some case, if you want, according to your requirement, then you can add the reinforcements. Okay? So when you add these three, okay, so matrix is nothing but a bonding agent. The matrix may be, for example, if you talk about the fiber matrix composite, in fiber matrix composites, the matrix is a resin, most probably the resin, because the percentage of resin is more than the fiber. That's why it is called a resin. The resin will act as a matrix. Whereas in metal matrix composite, let us say if you want to fabricate aluminum matrix composite, so aluminum play a major role in that. If you talk about a copper matrix composite, so copper play a major role over there. So the matrix is copper, whereas in aluminum matrix, the aluminum is the matrix. Okay, so when you add this matrix plus, in case if it is a fiber matrix, then you have to add fiber. If it is a metal matrix, you have to add the metal plus some amount of the reinforcement, and you can able to fabricate the final product composites, right? So how they are shipment of the composite in different years. The total shipment in 1995, the composites are used in transportation industries. They have been used 31%. In the construction industries, they are using 24%, and the marine industry, they are using 12% of composite material, and the corrosion resistant and equipment, they are using 12%. And even electrical electronics 10%, so you can see in the pie chart, most of the industries, okay, so day by day they are switching over towards the composite material, okay, because it is having that much of advantages when compared to the metal. Okay, that's why so most of the researchers are focusing towards the usage of this composite material. Now, so in a world market, what is the importance of this composite? You can see in aircraft industries, they are using more than 7.3 million product is manufactured by the dark blue is volume, and this is the value. So 7.3 million volume, they are using a composite material, especially in aircraft industries. Whereas in missile industry, they are using 5.1%, missile and space. Whereas in recreation industry, they are using 5% of composite material. In armor, they are using 4.3%. In automobile, 0.6%. Okay, so like that, in not only in India, in the world, in the entire world is focusing to use the composite, and the usage of composites are day by day is going to increases in different fields. And they want to accommodate the composite in a non-usable areas also. For example, in high temperature applications, let us say in nuclear power plant, it is not possible for me to use the composite material. But why can't I use this composite material for nuclear power plant? So still there is some research is going on. How can I use this composite material? I'm talking about the metal matrix composite. How can I use this metal matrix composite over in in the field of nuclear power plant? So in recent days there are more researchers which are going on this point. So what are the advantages of this composite material? Specific strength and stiffness, and tailored design. It has excellent fatigue life. It is having very good dimensional stability. The dimensional stability in the sense how you are manufacturing it is very much important. Otherwise, the dimensional stability, if there is some flaw in the fabrication, then you can't achieve this dimensional stability. So the fabrication, the method how you are fabricating this composite, then that will take care of this dimensional stability of the particular corrosion resistance. It's an excellent property, but you can't expect this corrosion resistance in a normal metal. Even if you use an aluminum will also corrode. Because when you place your aluminum in an atmosphere, in an oxygen atmosphere, definitely it will react with the oxygen and form alumina, Al2O3. Okay, so that will prevent the furthermore corrosion of the particular material. Okay, so corrosion is a major problem in normal engineering materials, but that can be rectified by using of these advanced composite materials, right? It is very cost-effective fabrication. You need not to bother about, you need not worried about, usage of big machines or, the machining or fabrication of the particular material. Okay, within a small, if you use a very small machines, then I can able to create, or I can able to fabricate this particular composite. And what are the drawbacks? So I know what are the advantages and what are the drawbacks of this composite material. It is high cost fabrication of the composite, because most probably, for example, if you want to fabricate a fiber matrix composite, most of them they will focus on the vacuum chamber, vacuum compression molding, because if it is a small component, then the cost of fabrication is very low. When, for example, if you want to fabricate a bigger size of component, okay, I think in one country they are going to develop the A360 Airbus entirely by manufacturing of this composite material, and you can imagine the size of Airbus. Okay, so that much of big components can be manufactured by composite, but the thing is that you should have that much of facilities in your factory to develop that particular composite. So it is cost effective. Okay, the complex mechanical characterization, some of the mechanical property you can't achieve it. You have to compromise any one of the property to enhance the other one. So that is another complex problem in mechanical characterization. Okay, right. So it can be high combination for all required property may not be available. So you can't expect excellent mechanical property. The composite should have an excellent mechanical property, excellent fatigue property, excellent free property, or excellent corrosion property. You can't put together all this all these characteristics should be available on a particular single composite. It is impossible. Okay, whatever the fabrication technique you have been adopted, even then it is not at all possible to fabricate, put together of all the mechanical, corrosion or tribological property at a single component. It's very difficult, right? And how can I compare the property of a composite versus a engineering metal? And you can see here. So this is the composite. The hatch lines are composite, and rest of them are a metal. Let us say this is an aluminum, and the lowest one is the polymer, and this is the titanium metal, and this is the steel metal. And this graph is drawn between the yield strength and the fracture toughness of different engineering materials and as well as the composite material. And you can see here, okay, so composites which will lie, it is not in the lower level and it is not in the higher level also. Okay, so it is somewhat better than the polymer matrix composite and slightly lower than the titanium matrix composites. So day by day, I think this is the trend, the recent trend, they are trying to enhance the fracture toughness of the composite material by doing some research day by day, and they like to try to, just push up the composite material in between the steel and or near to the titanium range, exactly at this range. Okay, so recent researchers, they are trying to push this fracture toughness of the composite material. And in this particular diagram, it shows that a comparison based on the 6 primary material selection parameters. For example, the hatch line, this area, this is entirely a composite material. The center one, sorry, this is the ceramic material, and the center one is the composite material. And the this light gray color, this one is a metal, normal metal. So you can expect the affordability, toughness, formability, and the joinability and the corrosion resistance. So you put together, it can able to, for example, it is having excellent affordability. You can see here. And it is having, when compared to the strength is excellent. But where it is lagging in the form of the, this jointability, very low. Because joining of composite, still there are some research are going on. So I think joining is nothing but welding of composite materials. So still there are more research which are going on by the joining of composite material. I think most of them, they are trying by using of the solid state welding. I think you know what is going to be solid state welding. Normal, this friction welding and friction stir weldings are good enough to join this composite material, but in normal fusion welding processes like MIG welding, TIG welding, submerged arc welding, shielded metal arc welding. So these fusion weldings are not been tried to join this composite material. So that's why in this diagram it shows that the weldability of the composite materials are in a very low region, and the formability is somewhat better, and the toughness, strength, and the affordability, these are in the higher order. Okay. So just now I told you that these are all the properties to which should I focus the composite material over the metal, normal engineering metal, right? So how can I focus those particular property in a composite material based upon the specific modulus, based upon the specific strength? I know specific modulus and the specific strength, which can give that very good mechanical property of a composite material. But these two are not at all sufficient for a composite to design. Okay, so if the composite is having excellent specific modulus or excellent specific strength, this is an essential property which can be expected from a composite, but these two properties is essential, but not only this are essential, some of the other properties also essential to to be required for the end user, right? In this particular diagram, you can see so day by day, from the year 1400 to around 2000, the year of 2000, the specific strength of the composites in 1400, the specific strength is just above 0.0102, something like that, for the bronze material, cast iron, steel, aluminum. And in the year 2000, it has reached in the around you can see in the 10, the specific strength of 10 into 10 power 6, okay, the carbon fibers and aramide fibers, right? And this is the chart which tell you the specific gravity, different mechanical property like Young's modulus, ultimate strength, the specific modulus, and specific strength different composite material. It may be a fiber matrix composites, or it may be a steel based or aluminum based metal matrix. And this is the chart which tells you the specific strength versus specific modulus of a different type of composite material. You can see the steel, which is lying in between 400, and whereas the specific modulus which is lying around 110 or something like that, 110 inch cube per this one, around this layer. But when you go for the graphite fiber and the unidirectional graphite and epoxy fiber, you can see the range, the specific modulus is around 450 or 460, and whereas the same specific strength around near to 4000. Okay. So when you use this composite materials, you can enhance the specific strength and specific modulus of a particular material. And just now I told you, the specific modulus and the specific strength is not only the parameters for measuring the advantages of the composite, okay? Because there are other type of properties which will enhance the mechanical and the metallurgical property of our composite material. Okay. For example, the engineer to meet the specific demand as the choice of making the material or many more compared to the metals. So they are selecting the different choice of the matrix, choice of the resin, and choice of the reinforcement, size of the reinforcement, volume of the reinforcement. So they are, even though they are trying it day by day, what could be the volume, what could be the shape, whether can I use a nano reinforcement or whether can I use a micro reinforcement, and so on. So by adding of this reinforcement or the increasing the volume or decreasing the volume of the reinforcement, that can enhance the the mechanical property of the particular composite. So first, that's why the fiber volume fraction, the layer orientation, the type of layer, the layer stacking sequence, I think these are all comes under the section of your fiber matrix composite. Whereas in metal matrix composite, the volume of the reinforcement, shape of the reinforcement, and shape in the sense it may be a spherical, it may be a irregular shape, and the size of the reinforcement, it may be a nano size, it may be a micro size, it may be a macro size. Okay, so these particular parameters which enhance the mechanical and the other property of a composite material. And this is another one important property for a composite material, that is a fatigue life. So the fatigue life is higher than the metals such as aluminum. So when you use an aluminum matrix composite, you can expect very good fatigue strength in the material. And the important consideration in the application of this aluminum matrix composite, most probably in the aircraft industries and the bridges and the structure exposed to the wind. Okay, so if you are going to use an windmill turbine blades, so it is, or normally it is exposed to the wind. So in those areas, I can use this aluminum matrix composite as a product. And based upon the dimensional stability, so dimensional stability, it may withstand the temperature. So even if there is some increase in the atmospheric temperature, so the structure should not deform. Okay, it should be stable enough. So if you are going to overheat a component, example, if you are going to use a metal matrix composite in the engine, or it may be used in the space structure. Okay, so due to this thermal effect, and not only the thermal effect, it may be the combination of the thermal effect and the fatigue behavior. So both will try to reduce the strength of the particular material. So in order to overcome those particular drawbacks, then you have to fabricate a composite to overcome those particular problems, right? Now, the other property is corrosion resistance. I think in a metal matrix composite, most probably we have to focus on the corrosion resistance. So in order to enhance the corrosion resistance, some of the different alloying elements are available, reinforcements are available to protect the corrosion problem on the particular material. So that I will discuss when we are going to discuss about the research part of this metal matrix composite. Okay. And where can I use this? Where can I, see the corrosion problem when you use this composite material? For example, if you use the underground storage tanks or doors, windows frames, and structural members of offshore, drilling platforms. So in those areas, if you are focusing to use your composite material, then that particular composite material should have excellent corrosion resistance. So what are the most limiting factors in the use of composite in structure? For example, if you want to use a composite in a structural application. So the thing is that most of the engineers, they are, they are in a very, lack of knowledge and experience to use this type of materials. Okay, and not only that, the cost considerations. So that's why they are not going to try this composite material for the structural applications. So because it is so expensive, okay, so that's why they are not trying this composite material for structural application. Still, they are using a normal engineering material. And the factors, the cost estimation. For example, the fabrication cost, transportation cost, then maintenance. The less maintenance than conventional materials is required. Okay, so based upon that, they are focusing this composite material, but they are not still used with this composite material for the structural applications. These composite materials are having, these are all the advantages when compared to the cost estimations. Okay, but still they are not using this composite material for structural application. Now I am going to discuss about the different type of composite materials. Based upon the matrix, I can classify this composite like polymer matrix, metal matrix, and ceramic matrix. So what is this advantages of metal matrix? It is having high strength and high modulus over than the metals, and it is having low coefficient of thermal expansion than metal by reinforcing with the graphite. As I think graphite is the reinforcement. So when you use a graphite, then you can expect very low coefficient of thermal expansion than compared to your normal engineering material. The maintenance of high strength property have excellent structural stability and withstand more thermal shocks or thermal load. Okay, so in that case, I can use this metal matrix. So what are the degradation properties in metal matrix composites? So in this figure, I think this 2A, I think you know that. What is this 2A? You might have seen somewhere else. This is the COD, crack opening displacement. This comes under the Griffith theory. I think you may know that. So if there is some notches in a particular material, let us say that the size of the notch is 2A. So when you add some, when you giving some different type of loading, it may be a compressive load, it may be a tensile load, or it may be a shear load. So based upon that, how the crack will propagate towards the other end of the particular material. So based upon the elongation of the crack, then I can able to find the fracture strength of the particular material based upon the Griffith theory. Okay, so in this metal matrix composite, the crack opening displacement is very important. The fracture toughness, you have to study fracture toughness, because why it is more important when compared to metal. In metal, all the these alloys, what are the things you are going to use for the fabrication, all are mixed together and they will look like a face. If you talk about in a metallurgical terminology, so all are in the form of a face if you see in a microstructure. But in a composite material, just now I told you, so all the particles, whatever the particle you are going to add in the particular composite, the structure may be a whole, but inside there won't be any bond between each and every particle. Okay, so in a composite material, the fracture toughness is a challenging job, because the crack, there are two types of crack growth. I think you all know that. One is IGC, another one is transgranular. Intergranular, another one is transgranular crack. So transgranular crack, intergranular crack. Intergranular crack will propagate, the crack will propagate through the grain boundary. Whereas in transgranular crack, the crack will propagate through the grain. But in composite, it is for the engineering material. What I'm saying that this is for engineering material. Whereas in composite material, all are in the all the particles are doesn't have any bonding between each other. It looks like such bonding, but basically there won't be any bonding between each other. So if there is a crack which will form in the particular composite, so that will propagate in the form of intergranular. So through the grain, through the particle, the crack will propagate at very faster. So that's why it is very important to study the fracture mechanics of your metal matrix composites. So these are the, here I am in this slide, you can see there are typical mechanical properties of a metal matrix composites. So you can see the specific gravity, Young's modulus around for silicon and aluminum. Aluminum is the matrix, AC is the particle, silicon carbide is the particle. So when you use aluminum matrix with a silicon carbide particle, and you can get around 17 MSI of Young's modulus, whereas if you use an aluminum matrix and if you are using graphite as a particle, then you will expect 18 MSI of Young's modulus. Like that, you can see steel is 30, the pure aluminum is 10. So when compared to the pure aluminum, the aluminum silicon and aluminum graphite, you can see the Young's modulus which is greater than the pure aluminum metal. So the composite, when you make a composite, you can expect or you can enhance the mechanical property like Young's modulus, tensile strength, compressive strength, coefficient of thermal expansion, coefficient of thermal conduction. Okay, so all these properties can be enhanced with appropriate selection of matrix, not only the matrix, appropriate selection of the reinforcement. Okay, and again, if you are going to select the appropriate reinforcement, even then you should focus what is the volume of the reinforcement should I add and how to add. Again, the adding of the reinforcement is also play a major role that I will discuss later, right? Now, this is the boron fiber. So low cost boron fiber. So how they are, I can show one by one. They are adding it in a particular matrix as a substrate. And this is the matrix, and this is the cutting shape of different reinforcement, how they are adding it. Applying of aluminum foil. So this top and bottom both are nothing but aluminum metal. Okay, aluminum matrix, and round shapes are nothing but the different aluminum foils. So the particle may not be, the reinforcement may be a particle, the reinforcement may be a structural. I think this is an example for the structural reinforcement. So I can use a reinforcement in the form of the aluminum foil. I think I started one research by adding of this aluminum foil by using it on aluminum matrix. Okay. And I got an excellent, I think, you can't add this aluminum foil as it is, because when you do some tensile stress or, some other shear stress, so the aluminum foil will peel off from the bonding. That we call it as a delamination. So in order to avoid this delamination, so while adding this aluminum foil, what should I do? You should do some holes at a different distance on your aluminum foils. Okay, that is called perforating. So you have to do some perforating holes. You have to do some perforating of a hole on the particular aluminum substrate at a constant distance. So then only the matrix will go into that particular hole and give some bonding between the aluminum matrix and the aluminum foil. So, okay, so that we'll discuss later. Okay, so these are all the alternate layer of the aluminum and the aluminum foil to enhance the strength of a particular aluminum matrix composites. And the fabrication, how they are doing this fabrication? The fabrication is done by the vacuum compression technique. Okay, because there I don't want to interrupt. I don't want to produce the air bubbles in between the aluminum foil and the matrix. So that will reduce your strength of the composite material. So in order to avoid that particular problem, most of the they will do it in a vacuum chamber, right? So by using the heat and vacuum, they will finally, you can see the structure. These are all aluminum foils, okay? But I think they have been used, these aluminum foils, in a different orientations, okay? For, I think the orientation also play a major role. I think in the previous slides I told you, in the fabrication of the fiber matrix composite, the orientation of the fiber play a major role. In metal matrix composite also, the I can't say it's the orientation, the distribution. Okay? Otherwise, if you are not properly distributing the particle inside the matrix, then what will happen? The agglomeration problem will come into picture. What is going to be agglomeration? Agglomeration is nothing but the cluster of all the particle will settle down at a particular location. So in that particular location, you will get an excellent property, but the rest of the area you can't get more strengths or more corrosion resistance or the other important properties. Okay, so in order to avoid that, so the distribution of particle in the matrix is a challenging job. Okay, so for that also you are doing the stirring actions. So when you do the stir casting techniques, so what is the purpose of using stir? So while stirring that molten metal, you can able to distribute the particles evenly on the entire volume of the metal. That's why we are going to use the stirring. And even in the stirring also, you should not use a maximum speed of stirring. So optimum stirrer speed should be selected. Otherwise, all the particles will be clustered at one side. Then you can't expect the even property on the entire matrix. Okay. And in this figure, you can see the combination of silicon carbide SiC versus the aluminum metal matrix. They are adding silicon carbide on the aluminum metal matrix composite, and how it looked like the hot mold silicon carbide aluminum. Okay, so this is the image of that particular. And this is the application of the MMC. I think metal matrix composites are used in many industries. I think in the introduction also I told you. Recent year, titanium matrix are used in a biomedical field for the to join the bones, joining of two bones inside the body, inside the human body. So nowadays they are using this titanium metal matrix the biomedical field, right? And this is an engine, okay, high strength, low weight. Okay, so the entire structure is made up of the metal matrix composites. Okay, the turbine engines. Okay, so you can imagine they are manufacturing this turbine engine with the help of metal matrix composite. So then, what are the properties should be that? So the turbine engine, you can imagine the temperature it can be withstand. So it have an excellent thermal resistance, and not only that, it should have an excellent structural stability. So that is also important. Okay, and not only that, it should have an excellent tribological property, wear resistance. Okay, so put together all, then they will they can they fabricate this engine part with the help of this metal matrix. Okay, and you can see the other application of this metal matrix. Aerospace plan, different aerospace industries they are using it, manufacturer, and structural component. Benefit is weight saving, higher operating temperature, and life cycle cost saving. Okay, most of them, the main part is the weight saving. And in metal matrix, there is another one matrix is called ceramic matrix. So the matrix is ceramics. So I think what are the different type of ceramics? So ceramics, it may be a metal oxide, it may be a metal carbide, it may be a metal nitrides. Okay, so when these metal with oxide or metal with carbide or metal with nitride, it comes under the category of ceramics. So when you use this particular matrix for the fabrication, then it is called a ceramic matrix composite. But the only drawback in ceramic matrix composite is so brittle in nature, because I think you all know that ceramics are brittle in nature. But The other rest of the property like hardness, strength, corrosion resistance, chemical resistance, wear resistance. So excellent when compared to other, composite material, ceramic metal composites is having excellent these properties. Okay, so ceramic matrix composite have a matrix of alumina. Alumina is nothing but aluminum oxide, Al2O3, calcium or alumino. Calcium alumino is a combination of calcium and alumina. Okay, calcium aluminosilicate, that is CAS, and lithium aluminosilicate, LAS. So these are all the some of the examples of a ceramic matrix composite or silicon carbide. So I think the major advantages of the ceramic matrix is having higher strength, higher hardness, high service to the temperature, high temperature application. I can use this one. Chemical resistance and low density. For the purpose, I'm going to use this ceramic matrix composites. And what is the matrix? Material can be used for the ceramic matrix composite. Aluminum alloy, silicon carbide, or silicon carbide plus alumina, silicon carbide and silicon carbide. It's a combination of both. Okay, so you can see the toughness, fracture toughness. So epoxy, if you use the epoxy, the fracture toughness is 2.73 KSI. Whereas if you use a silicon carbide, you can get 2.73. But the maximum, if you use an aluminum matrix, you can get 31.85 KSI is the fracture toughness value for the. And what about the other property like specific gravity and Young's modulus, ultimate strength of a ceramic matrix composite? So it comes under SiC, silicon carbide, and lithium aluminosilicate, that is 2.1, and Young's modulus is 13. Ultimate strength UTS is 72, and coefficient of thermal expansion 2 minute per degree. So I think how they are manufacturing this ceramic matrix composite, that is the slurry infiltration. So how they are doing it, I think in this figure you can be able to understand. So first of all, they are converting the glass into a fiber by using a slurry tank. Okay, so they are just passing this fiber in a slurry tank. In the slurry tank, it is consists of glass particles. So these glass particles will be embedded on the fiber material, and that will be passed through a particular die in order to reduce the diameter of the fiber, and that will be bonded. This is bonded on a particular wheel. Okay, so this glass impregnated fiber tapes are reinforced with the particular fiber matrix composites. Okay, now your fibers are not at all a pure fiber; it is not a natural fiber. So the natural fibers are, added with your glass particles. Now the strength of the fiber is enhanced with the reinforcement of or the addition of the ceramic. Glass is one type of ceramics. So with the addition of ceramics particle, and these particular fiber layers are oriented at different stacking sequence. And after that, they will go for hard pressing, and finally you will get a final product. So this is the elimination of ceramic matrix composites. Okay, so you can see the product. This is the fiber, but inside is embedded with the I think the previous diagram. It is embedded with the fiber ceramic reinforced fiber. Another type of composite is a carbon-carbon composite. It's a latest one. It's a carbon-carbon composites, which have a carbon fiber and carbon matrix. Both are in carbon. Matrix also carbon, and your fiber is also a carbon. Okay. When compared to normal metal matrix composite, this carbon-carbon matrix having excellent strength when compared to your it's a recent trend which is going on in this particular area. So gradual failure, withstand high temperature, low creep at high temperature, and low density, high thermal conductivity, low and tolerable coefficient of thermal expansion. So these are all the major advantages of the CC, is a carbon and carbon fiber composite material. Then the other property, like it is having high modulus, thermal conductivity, electrical conductivity, good thermal shock resistance, abrasive resistance, nothing but a wear resistant, excellent fracture strength, and it is having excellent, temperature resistant, durability, high temperature durability, and very good. And these are all the, the different property of a carbon-carbon matrix composite material. This is the diagram which will tell you how the fabrication of the carbon-carbon matrix is manufactured. Okay, so standard carbon and phenolic materials are used that can be layered. Is arranged by a stacking sequence, and after that they will go for cure. Then there is another one process, this called pyrolysis process. So after that, it will go to the resin impregnations. Again, it will be sent to this pyrolysis process. So after that, going for the coating, that is carbon coating. Then it is going for sealing process. So this is the way the carbon, because carbon is very brittle in nature, and you have to do this adding of carbon in the form of a coating. So that is the only way we can do it in carbon-carbon matrix. And most probably these carbon-carbon composites are used in aircraft, normally for the brake application, because its carbon is having very good hardness. If the hardness is more, then you can expect the wear resistance property. So it is having wear resistance property because the hardness is in the higher order. Okay. So so is it time over, or can I go ahead? Hello, sir. Are you there, sir?
Hello.
Time is over, or can I go forward?
Hello.
Madam?
Sir.
Is it time over, or can I go forward?
You can go forward, sir.
Okay. At what time should I complete?
Sir, your session is about complete, sir. Up to 12.
Okay.
12:10.
Up to 12:10.
Yes, sir.
11:10.
Oh, sorry, 11:10.
Okay, right. Okay, madam, I just take another 5 minutes.
Okay, sir.
Yeah, right. Okay. Thank you. So, so I like to give some small idea about the different analysis of the laminated composites, how they are, analyzing the property of laminated composites and how they are manufacturing it. So they will take a fiber. I think this comes under the fiber. Just a minute. Yeah. So the homogeneous body. Okay, it is an important property, isotropic body. The composite is an isotropic body, first of all, and the matrix should be a homogeneous, anisotropic, and it is having some lamina, or it may be a laminate. Okay, so the important thing is in metal matrix composite. So whatever the property you are going to expect, like mechanical, thermal, electrical, or even corrosion, wear resistance, and all. So you should select the appropriate matrix, whether it is an aluminum matrix, or whether it is a copper matrix, or whether it is a carbon-carbon matrix, or it may be a ceramic matrix. So based upon the applications, and again in a reverse, the end user is asking you to fabricate a composite which can be used in a high temperature application. Then your composite should have an excellent thermal resistance property and at higher temperature. So you should keep in mind that particular property, and you have to select the appropriate matrix, appropriate reinforcement, and the way of fabricating this particular composite, whether you can go for a strip casting method or whether you can go for a vacuum compression method. Okay, so based upon the property only, one can select the matrix, reinforcement, distribution of the reinforcement, and the fabrication techniques. So these 4 steps will play a major role to achieve the appropriate property in a particular composite material. Okay, so this is the a small idea about the composite material and its application and the the usage of this composite in a varied field, and how they are manufacturing this composite material by different things. Okay, so up to that I will stop. So participants, do you have any doubt? You can ask me.
Sir, few participants posted their questions in the chat box, sir. Please kindly go through that.
Yes, okay, definitely. So if you don't have any doubt, then I can like to wind up.
Yes, sir, sure, sir, definitely.
Yeah, okay.
Materials to 3D printing technology.
Sir, participants are posting question in the chat box, sir.
Yeah.
So how can use composite material to 3D printing technology?
How can I use the composite for 3D printing?
Yes, sir.
Okay, I think they are using polymer matrix composites. I think 3D printing they are trying in by using of polymer matrix composite, but still the research is going on by using of this metal matrix composite, because the mission, the appropriate mission, nowadays they are developing it to fabricate a metal matrix composite. But for polymer matrix composite, they tried and they succeed also. They are doing it. I think in our college also we are doing in fabrication of fiber matrix composite, polymer matrix composite with the help of 3D printing technique. There is layer by layer, addition of layer by layer at different sequence. Okay, but MMC is very difficult, and because the thing is that there is no option for the cost of the machine is very high. So in the foreign countries they are trying it to fabricate this particular material.
Madhusudan sir, can you directly unmute yourself so that you can directly ask the question?
Yeah.
And what about metal printing technology, sir? Someone asked a question.
Metal printing technology.
Yes, sir.
I think metal printing in the sense, you're talking about a composite or general? You're talking about, they are asking general or in
They have posted a question, what about metal printing technology? The same
metal, it is called additive manufacturing. I think I like to ask that question, additive manufacturing. So additive manufacturing comes under, is one type of welding. So layer by layer, we have to build the, the metal, to achieve a particular dimensions. So, for example, MIG welding and TIG welding, we are using those particular processes to develop layer by layer technique that is called additive manufacturing. It is that's why for making of 3D printing for a metal, still the research is going on, but in the way of welding route, they have been tried and most of them they are succeed also. Okay.
Okay, sir.
So what you are saying that there is additive manufacturing technique that can be possible in welding technique.
Sir, another question.
Yeah.
Right on functionally graded materials.
Functionally graded material. Yeah. Functionally graded material, madam?
Yes, sir.
No. What they're asking?
Please give some light on functionally graded materials.
Functionally graded material. I think it is a specific material. If you want to, stimulate a particular property, let us say, if you want to stimulate a creep property, or if you want to stimulate a particular fatigue property in a particular material, the rest of the property, I'm not going to disturb at all. Whatever is there, it like to be like that. But let us say I want to, increase, especially for a particular property, then I can go for functionally graded material. It is only for to enhance a particular function of the particular property. So for that, I am going to use the functionally graded material, and most of the research which is going on in this particular material, but it is slightly costlier and compared to normal engineering material. Sir, just like, I think you all know that shape memory alloy. Okay, yes. It is another version of shape memory alloy.
Sir, good morning, sir. This is Dr. Madhusudan.
Yes, sir.
Sir, I have a question for you regarding the modeling and the simulation as far as particle reinforced composites are concerned.
Yes, sir.
Generally, people are doing a lot of works based on the fiber reinforced composites, modeling and simulation, and final analysis. When they fail, what is the stress and so on.
Yes, sir.
So could you please give me a tip or maybe an idea how we can overcome the limitations as far as particle reinforced composites are concerned?
Particle reinforced composite for fiber matrix or metal matrix? Sir?
No, sir. For metal matrix, modeling and simulation and analysis.
Okay, so in that you have to use some optimization techniques, sir. There is some different optimization tools are there. Okay. So what is the volume of particle should I add? I think in that introduction also I told you. So the reinforcement, first of all, the matrix is a major problem, and second one is what are the particle you are going to use, whether it's a single particle or double particle or triple particles. I'm talking about the reinforcement. Okay, and the percentage of these two. Let us add, I think 5% of SIC or 10% of Al2O3. Okay, the combinations. One can I increase, one can I decrease, or both of them in the same order. Let us say 5%, 5%, or one is 0%, another one is 5%. So these combinations, when you vary this one, so you have to go for optimization tool, either L9, L27. Okay, so in that, and you can compare with the mechanical property, then you can select the appropriate volume fraction of the addition of the reinforcements. Because you can't do trial and error for each and everything.
Yes, sir.
So for that, you have to go for some optimization tools which are available. Either you can go for RSM or Taguchi and all there. So with the help of that, you can optimize the parameters. I'm talking about the volume fraction of these particles. And even not only that, even in the optimization tools, you can use the stirring, speed of stirring. That will also you can add. What could be the stirrer speed should I select? Because that is also play a major role. Let us say, can I use 500 RPM or 1000 RPM or 1500 RPM? If you are using a stir casting technique for fabrication of this MMC.
Yes, sir. So apart from these valuable inputs,
yes, sir.
How can you overcome this particle size or shape or maybe location of the particle when you stir in the matrix?
So this is very difficult, sir. Still, sir, it is very, I think if you publish a paper, so the first thing is that what they are asking, how you avoid this agglomeration problem in your matrix.
Yes, sir.
See, even then, if you take a microstructure after the fabrication, anyhow, you can't avoid this agglomeration problem.
Yes, sir.
Okay, so that will be there, but it should be minimum.
Yes, sir.
I can't say it should not be. It should not be a maximum. It should be a minimum range. Yes, but again, that agglomeration problem. Again, that the particle, the flying of the particle. If the particle having more density, yes, some of the particle will settle down at the bottom.
Yes, sir.
Some of the particle, if the density of the particle is in the lower order, that will float up on the top of the molten metal.
Yes, sir.
So you have to overcome that particular property, and not only that, the stirrer speed will also play a major role to distribute the particle evenly on the matrix. So still there is some trial and error is going on for optimizing this stirrer speed. I can't say this is the stirrer speed for the entire metal matrix. This is ridiculous. That depends upon the matrix, that depends upon the particle you are going to use, and not only that, what is the volume of the particle you have been added. If the volume is increased, again the agglomeration will come into picture.
Yes, sir.
You can't go more than 10%, 20%, 30%. I don't want to add more amount of reinforcement.
Yes, sir.
There is no meaning of that. Above some percentage of volume percentage of reinforcement, the property may not go in enhanced manner. It will come flat enough. The curve will go, in an inclined, in a horizontal way. So that for each and everything, there is some limitations. So this is the thing, sir.
Right, sir. Thank you. Thank you very much.
Thank you, sir. Thank you. So any questions, sir? Any question from the participants?
No, sir. Till now, no one posted a question here.
Okay, sir. Thank you.
Sir, shall we wind up the session, sir?
Yeah, definitely, sir. Definitely.
Yes, sir. Thank you so much, sir. Thank you so much for providing valuable information.
Yes, sir.
Participants, here I posted the feedback link. Kindly fill the feedback. Yes. Thank you. Thank you so much, sir. Dear participants, next session will be starting exactly 11:45. Kindly join the session. Next session.